Morning, good morning. We are diving into the next section. It lines up with page 7 in our notes, and specifically, we are going to be studying how we solve inequalities. So our topic is solving inequalities. And actually, we're going to also look at graphing them too, so you might want to add that. But how is this different from solving equations? What's the same? What's different? Could throw out compare and contrast, but we're just going to go with how is this different from solving equations? So the very first thing that I want to make sure we're all clear on is after we solve and get x alone, we graph the answer on a number line. So x is less than 3. Since it's less than, we put an open circle at the number. Arrow goes to the left. We want all the numbers smaller. If it's less than or equal to 3, we do a closed circle. And the arrow still goes left to get the number smaller. X greater than 3 is an open circle to the right. Greater than or equal to is closed circle to the right. So in general, if we're going to just kind of trap some of this information, less than and greater than get open circles. Less than or equal to, greater than or equal to, get filled in circles. Okay? And we've done some stuff with filled in circles and whatnot, so hopefully that feels a little bit familiar. I want to run through 2 quick examples with you. So I'm going to call this example A. I'm going to call this example B. Example A, x minus 6 is less than or equal to 15 plus 8x. So if you remember from solving, we are going to probably want to get all of our x's on the same side. I am going to subtract this x because I always like to move the one that's a little bit smaller. I think that's sometimes easier to work with and hopefully avoid negatives down the road. I'm going to subtract my 15 because it's in the way of x being by itself. Finish by dividing. That has not changed. And I get negative 3 is less than or equal to x. Now, when we come back up here to our table, this looks a little bit like what we see up here, but it's hard to see which way the arrow should go when it's not written x is whatever. This is written negative 3 and then go to x, okay? And so it might be helpful for us to flip it in our brain. X is greater than or equal to negative 3. These mean the same thing. And the reason we can tell they mean the same thing is look at where the less than is opening to. The 2 dots, so to speak, is pointing to x. And so when we flip it around, we need to acknowledge that. So now we're going to come down and graph. First of all, I need a number line. Negative 3 is kind of the key number. If I go closer to 0, I can go that way. If I go further from 0 to the left, this is going to take a closed circle. We are going to the right. And I know that feels funny compared to what we saw when we solved the problem, but that's why we want to speak in terms of what do we know about x. Second example. Let's dabble in some distributive property here, shall we? I know I'm excited too. I'm going to distribute that negative 5. Subtract 20. And finish by dividing by negative 5. Now, we're going to get x and we're going to get 2, but when we finish by dividing or multiplying, by a negative coefficient, flip the symbol. Okay, good talk. That means that this greater than has now become a less than, which means that when we dive into our number line, that is going to impact how we draw it. I've got a 2. If I go to the right, I get bigger. If I go to the left, I get smaller, and we are going to end up in some negatives. Because this is x is less than gets an open circle, and then I want all the numbers x less than, so my arrow is going to go to the left. Good talk. Write this down. Own your greatness. Solve your problems. You got this. I believe in you.